Hello, I'm Ada from the HeartCount team. Welcome to our 5th webinar. Today, we'll explore the fascinating world of behavior-based segment analysis, a method that enables better understanding and engagement with different customer groups. So if you're new here, let me briefly introduce HeartCount. HeartCount is a data analytics tool designed to empower practitioners in their decision-making processes. Feel free to visit our homepage and try out our visualizations for free by scanning the QR code on this slide or the link below in the description. We're also excited to announce our community website, Don't Data Me Alone. We've playfully used the word data as a verb here and will be updating the site with content ranging from the basics to practical applications using HeartCount. It's a place where data bonds overcome data bounds. Now let's jump right into our webinar. Today's focus is on segmentation analysis, and we'll be using insurance claims data for our exercises. This dataset includes demographic information and medical claims details. Our goal is to understand the characteristics of individuals who have claimed medical insurance versus those who haven't. Segmentation involves dividing a customer base into homogeneous groups based on various characteristics. It is crucial for maximizing business outcomes such as sales or conversions. Unlike other techniques that focus on changing customer behavior, segmentation aims to identify and target groups more likely to exhibit desirable behaviors. So it is important to distinguish segmentation from A/B testing. While A/B testing focuses on understanding which version of a product or service leads to better outcomes, segmentation focuses on understanding customer characteristics and targeting specific groups more effectively. So we can apply these concepts to our insurance claims data. We can compare individuals who have made a medical claim in the last 6 months to those who haven't, looking for statistically significant differences in characteristics such as age. Although there will be overlap, identifying these differences can provide valuable insights for targeted interventions. In summary, whether you're dealing with digital businesses or traditional industries, segmentation is a powerful tool for understanding and targeting specific customer groups. By analyzing behavior and characteristics, we can optimize business outcomes and create more effective strategies. Next, we'll be diving into statistical tests, specifically focusing on the t-test. While there are various tests like ANOVA for comparing multiple groups and chi-square for category test, our focus will be on the t-test. A t-test is a statistical test used to compare the means of two groups to see if there is a significant difference between them. This method was developed about 100 years ago by a statistician named William Seeley Gossett, working under Guinness Brewing Company. Due to company policy, he published his work under the pseudonym Student, leading to the name Student's T-Test. Gossett's main goal was to ensure the ingredients used didn't compromise the beer's quality. Before the t-test, we had the z-test, which wasn't suitable for small sample sizes. Gossett introduced the t-test as a more robust method for these situations. Statistical tests help us understand if observed differences in data, such as life expectancy between genders or beer quality from different ingredients, are significant or just due to chance. We use t-tests to compare two groups. For instance, let's say red is the lifespan of women and blue for the men. The calculation involves the mean, standard deviation, and sample size. The t-value obtained helps us determine if the observed difference is statistically significant. Let's consider an example where we compare barley for two different fields using the t-test. We calculate the t-value based on average yield, variation, and sample size from both fields, which is 2.3. A t-value beyond a certain threshold indicates a significant difference. In this case, it's 2.04 since 0.05 is used most often. Furthermore, degree of freedom is a total number of observations minus the number of parameters being estimated, and in this case it's around 30. In today's world, we often work with entire populations rather than samples, making some traditional statistical methods less necessary. However, understanding these concepts is still crucial for robust data analysis and making convincing arguments. Analyzing distributions is key in data analysis. Histograms and frequency table are valuable tools for visualizing and understanding distributions. They help in making sense of data and drawing meaningful conclusions. As an example, let's look at the distribution of weekly work hours across employees in a company. By categorizing the hours into bins and visualizing them through a histogram, we gain insights into the work patterns and can make informed decisions. Taking it a step further, reducing class intervals from 4 hours to 1 hour to 30 minutes or 1 minute transforms our histogram into a smooth curve known as probability density function. This continuous curve illustrates the likelihood of different work hour ranges, a concept now widely utilized in business analytics for better data insight. Above, you'll see a histogram detailing the overtime of managers in blue versus non-managers, and below it, a smooth curve representing the same information as a continuous probability density function. A t-test might indicate a difference in overtime hours between the two groups, but you can often see the disparity clearly even without the test. It's crucial to remember, statistical significance doesn't necessarily imply a large or meaningful difference, and it merely confirms that the observed difference isn't likely due to random chance alone. Observing such a clear distinction in the data distributions for our sample population suggests a substantial, practical difference between the two groups beyond mere statistical significance. Let's consider another example. A time series graph of MET scores for men and women, and on the upper right, the average income of day laborers in the US and Mexico. Both data sets show visible differences. For our analysis, let's isolate the year 2016 and ask, is there a significant difference in MET scores between the genders? When we analyze distributions, we see a distinct difference in means, but considerable overlap in the distributions, indicating a natural variance. For the income levels of day laborers in the US versus Mexico, however, not only is there a notable mean difference, but the distributions also significantly diverge. This suggests US workers typically earn more than their Mexican counterparts, which is evident without any formal testing. And for the upcoming demonstration, I've prepped our dataset. Individuals hospitalized in the last 6 months are marked yes and represented in blue, while those not are in pink. Focusing on the body mass index, we notice a pronounced rightward skew in the distribution for those who have been hospitalized. It's apparent that the obesity index significantly differentiates the two groups, a fact that would be clearly supported by a t-test. There are various classification methods to distinguish between two populations, such as wolves and cows, using known variables. I'll explain the differences between linear classifiers, like this logistic classifiers, and nonlinear ones like support vector machines, highlighting the transparency and linguistic interpretability of decision trees. Using a decision tree, we can convert complex data into straightforward rules. For example, we could use it to predict employee performance based on personality test results and extracurricular activities, creating a model to apply to unknown data. As we further explore, implementing decision trees for classification showcases its efficacy. By plotting known variables on axes, decision trees facilitate the classification and segmentation of data, in this case, separating high performers from the others, the stars to the triangles. So in a hypothetical scenario, club experience and perseverance or endurance score are employed to identify high performers. This segmentation will be demonstrated using node analysis, allowing us to establish rules that pre-filter high performers with high accuracy. Similarly, for our hospitalization data, a decision tree could unearth rules for identifying individuals based on their hospitalization status in the last 6 months. This can be done at ease using our HeartCount tool or by R or Python as well. So moving on, we're going to navigate through a dataset from an insurance company that I've already mentioned in the first slide here. So this is about information on individuals who have made at least one medical claim, and I'll give you this link in the description below, so don't worry. So this data set includes variables such as age, gender, BMI, activity level, children, smoking status, region, medical costs, and hospitalized status in the last 6 months. Our goal is to identify differences between those who are hospitalized in the last 6 months and those who weren't, aiming to pinpoint characteristics that could help target individuals who did not get hospitalized. So now let's log into HeartCount. You can just simply click on the link here. I've already opened it. And then you can just drag and drop the insurance data set here. Okay, so upon preliminary examination of the data, we observe various distributions for different variables like age, gender, and BMI. So before diving into statistical analysis, understanding these distributions is crucial. You see the distribution of age again, and the number of men and women is about the same. And BMI is normally distributed. The activity level or the steps per day actually has an odd distribution. Then the number of children, smoking status, neighborhood, medical costs, and so on. So let's click continue and start EDA. I'm actually going to upload this campaign first in order to use the advanced analysis function afterwards. Okay, so when examining whether there's a difference in body mass index between individuals who have been hospitalized within the last 6 months and those who haven't, we generally look at the distribution, right? Here, click this. Now, if we compare their averages, it becomes evident that overall those who were hospitalized incurred higher medical cost, and the average medical expenses for those hospitalized recently was 32 point something compared to 27 for those who were not. However, our question is whether this difference is substantial or statistically different. We can discuss this by looking at the box plot again, the distribution, or if necessary, delve directly into statistical significance. A quick way to determine significance is by checking if the 95% confidence intervals here overlap. But if they don't, it implies a statistically significant difference. Moreover, when we look at the distribution, possibly in a file-in chart format, we can visually confirm that those hospitalized recently tend to have a higher BMI. And similarly, we can conduct analysis on medical costs as well. And while it's feasible to compare each variable one by one when there aren't as many, it becomes impractical with dozens or hundreds of variables due to time constraints. Therefore, we'll show you the difference analysis feature. Here, I'm going to zoom in a bit. Okay, on one side, we have those who are not hospitalized in the last 10 months, considered the healthier group. On the other side, marked in red, are those who have been hospitalized at least once in the same period. We aim to compare the statistical characteristics of these two groups. So let's take a brief look at the results. Here. Essentially, what HeartCount's difference analysis feature does is plot the probability density functions, which helps in comparing the statistical characteristics of the two groups. Here. So the less these functions overlap, the more pronounced the difference between the groups, like the ones in the first part here. So for instance, the number of children in BMI shows significant non-overlapping areas in their distributions, indicating these variables as potential differentiators. And similarly, the distribution of, I'm going to eliminate derived variables, then try it again. Okay, that's better. And now let's see that the distribution of medical cost also skews higher, and we can observe this trend for smoking status here as well. So to simplify, let's only consider smoking status and get rid of the others, and then apply. To cut to the chase, smoking status emerges as a significant characteristic differentiating the two groups. So difference analysis is revealing that a higher percentage of individuals who were hospitalized in the last 6 months smoke compared to those who weren't. Let's see here. For example, of the 783 individuals hospitalized recently, 31% were smokers. In contrast, only 4.5% of the 555 people who were not hospitalized smoked. This significant difference suggests that smoking status is a meaningful characteristic when distinguishing between these groups. However, it is more appropriate to consider the relative importance of these characteristics regarding its potential impact and controllability in a broader healthcare or insurance context. So to reiterate, the statistical difference in characteristics traditionally analyzed through algorithms like the chi-square or t-test could alternatively be visualized through probability density functions. And for practical purposes, what could this mean again? Let's see. This mean to marketers. It's essential to recognize the features that distinguish between groups using simple visualizations of probability density functions rather than just relying on traditional tests. It could help them predict and influence future behavior as well, leading to more personalized and effective marketing. So that was why and how to use difference analysis feature. And shifting gears, let's dive into decision tree analysis to derive rules for classifying individuals based on their hospitalization status in the last 6 months. And click run. Okay, I'm going to zoom out a little bit. Click this icon right here. So for example, right here, 436 individuals had an obesity index above 25.98 and had no children. So all of them had been hospitalized within the last 6 months. This condition would be an excellent targeting factor if we were to look for recently hospitalized individuals. And conversely, if we aim to market health insurance, targeting these criteria may be advantageous regardless of ethical considerations. Although decision trees are used as predictive models, they are extremely helpful in marketing to identify characteristics that distinguish between groups based on different behaviors. So let me add one more point here. The conditions we can target might vary. For instance, we might not know certain variables like BMI, recent history of hospitalization, medical cost, and steps per day. But if we do know about age, children, region, gender, and smoker, we can still develop a targeting condition based on these available variables. Like this. So this is all that I've got for today. We've reached to the end of today's webinar, and I hope you found our discussion on behavior-based segment analysis enlightening. We look forward to seeing you in our 6th webinar. So until then, feel free to explore our community site, Don't Data Me Alone, and sign into our product as well. So thank you once again, and see you next time.